The problem statement in question 8 is as follows. An AP consists of 50 terms, of which the third term is 12 and the last term is 106. We have to find the 29th term of this AP. Now this question is very similar to the last question of this exercise. It has only been restated a little differently. So we are given that the third term is 12, so T3 is 12, and we are given that the last term is 106, but we also know the index of the last term because we are told that the AP has 50 terms. So we have T3 which is equal to 12 and we have T50 which is equal to 106, and using these two pieces of information we have to find the 29th term. So just like in the last question, there are two slightly different approaches to solve this. One is a more visual approach and one is a more algebraic approach. So let me show you both in this case, just as I did in the last question as well. So here's a visualization of this AP. So we have T3 as 12 and we have T50 as 106, and using this we have to find T29. Now the obvious thing to do is to find the common difference, and to do that we observe that to go from T3 to T50, to go from the third term to the 50th term, how many jumps of D will it take? How many jumps of the common difference will it take? Well, because 50 minus 3 is equal to 47, it will take us 47 jumps of D or 47D to go from the third term to the 50th term, and the change in the two terms is from 12 to 106, and that is a difference of 94. So this means that 47D must be equal to 94, and this immediately gives us D. D is equal to 94 by 47 or 2. So the common difference is 2, and now to find T29, all we have to do is we have to find out how many jumps of D will it take to go from T3, the third term, to the 29th term. So 29 minus 3 is 26, so it will take us 26 jumps of D to go from T3 to T29. Now how much is 26D? So 26D is equal to 26 into 2 or 52. So this means that T29 is equal to the third term 12, because we have to take the third term because this is where we are calculating the difference from. So 12 plus 26 jumps of D, so 12 plus 52 or 64. So the 29th term is equal to 64. Now let me show you a more algebraic way of doing the exact same thing. So we are going to assume that the first term of the AP, because that's not given, we are going to assume it as A, and we are going to take the common difference as D. Now we are told that the third term is 12, so T3 is 12 and T50, the 50th term, is equal to 106. So T3 I can write in terms of A and D as A plus N minus D or A plus 2D, because N minus 1 is 2 in this case. So A plus 2D is 12, and T50 I can write as A plus 49D, 50 minus 1. So A plus 49D, this is equal to 106. And once again, just like in the last question, you can solve this pair of linear equations in A and D by elimination. So you subtract this first equation from this second equation, you will get 47D on the left side and 94 on the right side. And this is the exact same equation you got earlier using the more visual approach. So 47D is equal to 94, or D is equal to 94 by 47 or 2. Now using this, let's find the value of A. Let's substitute this value of D into the first equation. So we get A plus 2D or A plus 4 is equal to 12, and this means that A is equal to 8. So the first term of the AP is 8. Note that we did not need the first term in the first approach that we followed because we were only calculating difference between terms. But in this second algebraic approach, we calculated D, and using that we also calculated A. And now to calculate T29, we can simply use the relation for the nth term. So that's A plus 28D, A plus 28D, and now A, so let's plug in the values for A and D. A is 8 and D is 2. So 28 into 2 is 56. 56 plus 8 is 64. So this answer is what we got earlier also. So the 29th term of this AP is 64, and that solves question number 8. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.